In this unit, we've talked about the cell cycle and how it includes interphase and mitosis. Mitosis is the cell division phase of the cell cycle. And we've also noted how the cell cycle is divided up into three different phases, right, where growth happens and DNA changes, and it goes from being in a chromosome form to being unraveled, then it's copied, and then we double the number of organelles so that we can divide into two cells. There is a whole lot of activity happening, and some of you may be wondering, or not, how are all of these events so tightly regulated? If you think about it, our cells are dividing constantly, and some of them are dividing daily, some less frequently. But how are all of these events controlled so well that we end up making identical daughter cells every single time? Okay? We haven't even talked about how easy it is for mutations to happen and how that copying process occurs. But we're going to look at how this whole process of the cell cycle is regulated or controlled. Okay? So let's dive in. Let's look at a few different occupations, right? Jobs that people have. Some people are nurses, custodians, police officers, or a DNA proofreader. Okay, DNA proofreader is actually going to be a protein. Remember, they do all the work in the cells. The nurses, I'm just going to flip to the next slide here. Okay, in class we'd probably fill them out, but each protein has one job. If you're a nurse, you take care of patients. Okay, if you're a custodian, you do cleanup. Police officers protect citizens, and DNA proofreaders, surprise, surprise, proofread the DNA. If the nurse is gone, patients can die, right? They don't necessarily die. Maybe they can, hobble to the bathroom on their own, but it's not good that we need nurses to take care of patients. If our custodians decided to just walk out on us, we would have so much trash in our rooms. We'd have to do some of that cleanup ourselves. So very thankful for our custodians. We would have a lot of crime if we didn't have police officers. And if DNA proofreader was gone, we might have some typos, otherwise known as mutations, in our DNA. Okay, so just like these different occupations, each protein has one job, and when they don't do it, there are consequences. Okay, so when those jobs don't get done well or at all, the cell suffers. Okay, so now let's think about each of these jobs and how there's often a supervisor. Okay, if you're a nurse, you're probably supervised by a head nurse, right? A department nurse, I don't know, the head of the ward, right? And there's maybe a chief custodian who needs to sign off on the work that the other custodians are doing. There's a chief of police, right? How does having a supervisor impact these jobs? If you have a supervisor, you're probably going to do your job a little better, right? And if a nurse makes a mistake, it's the supervisor's job to catch that. If the custodian forgets a room, it's the supervisor's job to say, hey, you need to go back and clean up, right? So in our cells, the checkpoint proteins, sometimes we just call them checkpoints, these are the supervisors of all that needs to happen in the cell. Okay, so write that down somewhere. Checkpoint proteins are the supervisors of the cell. Proteins are doing jobs all throughout the cell cycle in all sorts of processes, but then there are proteins, checkpoint proteins, that actually supervise their work. Okay, they don't have a clipboard per se, but if that helps you remember that, go for it. So let's take a look at some of these supervisory roles. Okay, each of these checkpoints is a protein, like I said, and it occurs, and these occur actually throughout the cell cycle. We're going to go over three, but the idea is the same throughout. Okay, if you have your packet out right now, pick one of the cell cycle diagrams, either the one on the cover or on page 3 after the reading, and add this information in because this is really important. Okay, so in G1, we've just come out of mitosis, right? The cell has divided and we went from tightly packed chromosomes to unraveled DNA. At this point, there is a checkpoint protein that checks the work of mitosis, right? Is the DNA damaged at all from division? Okay. If it is, then the DNA is either repaired if it's a small minor mistake or damage, and if it can't be repaired, the cell is tagged for the trash. Okay. Apoptosis is the self-destruction of cells. This is also a good word to put down somewhere. Apoptosis is when cells are destroyed. Okay, they're kind of marked for the trash bin, and they are sent to basically self-destruct. Okay, so one protein that checks over the work following mitosis. Okay, so in each case, we want to look at what just happened and what might they be checking for. Okay, so let's look at the next one. There's a synthesis checkpoint protein. Okay, if you can remember what happened in G1, right? We had a lot of growth and the DNA was unraveled. And then in synthesis, we're copying the DNA. So the checkpoint protein is probably checking the work of synthesis, right? Was DNA copied correctly? Were there any errors? Okay, again, if the errors can be fixed, they're going to fix those. Guess who does the work of the fixing? Also proteins, okay? If they can't be fixed, there's actually a protein that is attached to the cell and sent to the trash bin, okay? So here's another checkpoint protein. Add this information to your cell diagram. Go ahead and pause this video and write that in. All right, and then the third checkpoint protein is in G2, okay? Again, there are lots of other checkpoints along the way that happen, but these are 3 that we're bringing up, okay? In G2, we are preparing for mitosis, and a lot of things have happened up to this point. So the G2 checkpoint protein is asking the question, is the cell ready to divide? Excuse me. Are there enough copies of the genetic material, right? Are there enough copies of the DNA? And are there enough cell organelles? Okay, we need both of these bullet points. We need enough DNA for 2 cells, and we need enough organelles for 2 cells. If either is insufficient, okay, if we don't have enough DNA, or if there are not enough organelles, the checkpoint will communicate to the cell, hey, you need to fix this, and if you can't fix it, we need to send this cell to the trash. Okay, now, if this checkpoint doesn't do its job, or this one doesn't do its job, then the cell's going to continue on through the cell cycle, and those mistakes, those errors that happen might not get caught. Okay, so that's the danger of if there's a mutation in the recipe that makes up the checkpoint protein, then you could have a faulty checkpoint. Okay? It's like not having a supervisor in a hospital ward, or not having a supervisor at a company. Okay, so if the checkpoint proteins don't work, here's a different diagram, right? Don't get don't get overwhelmed by a new diagram. This is the same idea. We've got mitosis here, G1, synthesis, and G2. Okay. If the checkpoint here is not working, you might have some chromosomes that are misaligned. Okay. They might not have come out of mitosis all right. Okay. If you have a checkpoint here that is not working, you might end up with unreplicated or damaged DNA because it was their job to check that part of the process, right? If this checkpoint protein is broken or it's not working well, then you might have unreplicated, right, not copied, or damaged DNA because that was their job to make sure that it was okay after synthesis. Over here, this G1 checkpoint protein doesn't do it. You might end up with damaged DNA. Okay, there seems like there's a lot of overlap here, but essentially this is the value of the checkpoints. Okay, so they are the supervisors, and they are protein supervisors of all the many things that need to happen in the cell. Okay, so let's take a look at this. This is a little bit of a tricky question. This is from College Board, but I want to go over this. The cell cycle contains certain checkpoints that have an important role in regulating cell division. A checkpoint during G2 checks that all of the DNA was properly replicated. Which of the following best predicts the effect of a malfunction, so it's not working, right, of the G2 checkpoint on the cell? Okay, so sometimes when you have a lot of text like this, you have to reword it. Which of the following best predicts? What is the effect of a broken G2 checkpoint on the cell? If the G2 supervisor is not working, how is the cell affected? Okay, and they say in the text here, a checkpoint during G2 checks that all of the DNA was properly replicated. If this guy is broken, this is not functioning well, then this job of theirs is not going to happen. Okay, so the DNA was not properly replicated in synthesis phase. You know what part of the cell cycle that is. So let's look through the options. Okay, the cell will continue to divide, but some of the daughter cells may be missing DNA. The daughter cells are the two identical cells that are coming out of mitosis. Yeah, they could be missing DNA. Let's see what the other options are. And the cell could continue to divide with incorrect DNA. The cell will continue to divide, but the daughter cells will likely have the wrong number of chromosomes. These two seem very similar to me. So we're going to come back to these. See if we can eliminate any others. The cell will continue to divide, but the daughter cells will likely be too small to function properly. Now, this G2 checkpoint was just checking that all of the DNA was properly replicated. Its job was not to check the size of the cells. So we can eliminate C. Okay. D is the cell will stop dividing until the malfunction of the G2 checkpoint is corrected. If the supervisor is not there, calling out the proteins for shoddy relationship, then no one's going to stop them, right? It's the supervisor's job to say, hold on, you did that wrong. We need to fix it or send it to the trash. So D is also incorrect. So it's between A and B. The difference here, this is a slight difference, but some of the daughter cells may be missing DNA versus the daughter cells will likely have the wrong number of chromosomes. Now, seems like it's kind of similar here. The daughter cells are not likely to have the wrong number of chromosomes. The job usually gets done okay, but it's possible that missing DNA could make it through the cell cycle. Okay, so A kind of highlights the fact that it's a rare occasion that DNA is missing, whereas this one kind of says like if the supervisor is gone, the nurse is very likely to kill one of her patients. That's a horrible example, but hopefully that kind of illustrates it. If the supervisor is gone, the nurse will continue to do her work and things will probably be okay, but some mistakes may be entering in the picture. Okay, so this would be the correct answer in this case for A. So maybe take a closer look at that and make sure all of your notes are updated in your packet. Okay, hopefully that is helpful to talk about the checkpoints, which are the protein supervisors of the cell.